Welcome to Math Story.
And hello everyone. Today we are going to solve 5 interesting problems based on limit of the function, and especially the indeterminate form of the type 0 power 0, infinity power 0 and 1 power infinity for some problems. Now let's start with the first problem. Limit x tends to 1 secant pi by 2 into x log 1 by x equal to what? Let me rewrite this term as log 1 by x divided by, comes to the secant pi by 2x, comes to the denominator, we get cos pi by 2 into x, right? Now we applying the limit directly, we get when limit x tends x approaches to 1, the log of 1 by x is approached to 0, right? Then cos pi by 2, the value is 0. 0 by 0 is in indeterminate form. We can use here the hospital rule, right? Now differentiating numerator and denominator with respect to x. First I'll differentiating log 1 by x, I get 1 divided by 1 by x, and again differentiating 1 by x, I get 1 by minus 1 by x square, right? And divided by, we differentiating cos pi by 2 into x, we get minus pi by 2 into sine pi by 2 into x, right? Now here the x is come upon the numerator, we can cancel out these terms like this, and we again applying the limit extended can convert into the same terms, minus 1 by x divided by minus pi by 2 into sine pi by 2 into x. We can applying the limit now, can cancel out the minus here, and applying limit extends to 1, we can convert it into the 1 divided by pi by 2. The sine pi by 2 value is 1, already we know that, and which means 2 by pi. Here now the answer of limit extends to 1 secant of pi by 2 into x log of 1 by x is 2 by pi. And now we are going to solve another one important and interesting problem. Limit extends to 0 cot x power sine x equal to what? Okay, it just applying the limit on directly, we get cot x value as infinitive and sine x value 0, right? It means the 0 power infinitive form. Okay, now I took the value for cot x power sine x, like y equal to cot x power sine x, right? We are actually, I took the name to his cot x power sine x as a y, right? And we are now going to, I think, log on both sides, we get log y equal to log of cot x power sine x. We know that log of a power b equal to, we can written as a log b log a, right? So that we can see written as sine x a log cot x, like this. Okay, now let us applying the limit on both sides. Limit extends to 0 log y, we get limit x tends to 0, and I'll rewrite this log cot x divided by cosecant x, right? Now applying the limits at directly, we get we know that the cot x value of the cot x means as infinitive, right? Log cot x means as infinitive, and cosecant x also a infinitive, right? And which means that infinity divided by infinity form, we can use the L'Hospital rule here, and limit extends to 0, differentiating with respect to x on the numerator log quad x changes as, when we differentiating log quad x, we get 1 divided by quad x, and differentiating quad x we get minus cosecant square x, right? And again we differentiate about denominator, we get minus quad x into cosecant x. Okay, and now I'll cancel out in these terms, cos x, cos square x actually here, and I down upon this cot x, actually I'll get and cancel upon the negative terms, and I'll get the terms limit extends to 0 cosecant x divided by cot square x, right? Now before going to applying the limit, I'll first change the order here, actually alternating some order here. Limit extends to 0, I'll change, like we can written as the cot square x as cos square x divided by sin square x, right? And we can write cosecant x as 1 by sin x. We can cancel out the 1 sin x here. Then finally we get limit extends to 0, then actually the sin x divided by cos square x. We are applying the 0 right now. We get the value sin 0 divided by cos square 0. Here the value of sin 0 is 0 and the value of the cos 0 is 1. That means a 0. 0 is not an answer for this question. Here now we get the 0 is the answer of limit extends to 0 log y, right? Now the 0 is the answer of limit extends to 0 log y equal to 0, right? We need the solution limit extends to 0 y equal to some element, right? Now we are taking exponential on both sides. We'll get a limit extends to 0, exponential and logarithm cancelled out, we get limit extends to 0 y equal to e power 0, right? So that limit extends to 0, y means 1, e power value of e power 0, right? Here the answer is limit extends to 0 cot x whole power x sin x, means the value 1 is the final answer of this question. And the next sum is limit extends to 0 of 1 plus x whole power 1 by x. We are applying the limit directly, we get the value. When applying 0 on this side, we get 1 plus 0 per infinity, that means 1 per infinity, right? And now we solve this problem using the same trick like the second one. Now I just take the value of 1 plus x whole power 1 by x as y, and now we are trying to prove limit extends to 0 y, right? And now I taking log on both sides here means let the value, right? And taking log on both sides, we get log y equal to log of 1 plus x 1 by x actually, and the value come out the 1 by x, we get 1 by x log 1 plus x actually, right? And now here I'll like to applying the limit on both sides. Limit extends to 0 log y means limit extends to 0 log 1 plus x divided by x. Okay, and now we are applying the limit on both sides. We get the value log 1 divided by 0. That means 0 divided by 0 form. We can using here the hospital rule. Okay, then we are just applying differentiating on both sides. We get what, and directly I'll applying the differentiating this term with respect to 0, sorry, with respect to x, we get 1 by 1 plus x, right? The denominator gets 1. Okay, now we are applying the value of x as 0. We get the value 1 here. It's not a solution for the given problem. Now it's the solution for limit extends to 0 log y, right? But our original solution is limit extends to 0 y, right? Now I'll taking exponential on both sides. We get limit extends to 0 y. Actually the exponential and logarithm would be cancelled, e power 1. That means the solution of limit extends to 0 of 1 plus x whole power 1 by x is e power 1. Now we are trying to prove the fourth one problem. Limit extends to 0 1 plus sin x whole power cot x, right? I'll applying the limit on directly. We get 1 plus sin x, sin 0 means 0, right? So 1 power cot 0 value is an infinitive actually. Okay, and 1 power infinity form. The name as y actually here. So we get 1 plus sin x whole power cot x, right? And taking log on both sides, we get cot x into logarithm of 1 plus sin x. I can rewrite this term as 1 plus sin x divided by tan x, right? I'll taking a limit on both sides as x tends to 0. Log y means the limit x tends to 0 log of 1 plus sin x divided by a tan x. Okay, I'll applying the limit here, and when I applying the 0 here, I get numerator as a log 1. Log 1 value is 0, right? And actually then tan 0 values also is 0. So 0 divided by 0 indeterminate form. We can use the L'Hospital rule here. And now we are applying these terms for the L'Hospital rule. First I differentiating log of 1 by 1 plus sin x, right? I get 1 divided by 1 plus sin x here. Now I differentiating 1 plus sin x. I'll get 1 as a 0, and I differentiating with respect to x as sin x. We get a cos x. Then we going to the denominator. We differentiating the tan x as with respect to x. We get secant square x, right? Actually secant square x. And now we are applying the limit on this time. Limit extends to 0, the cos x goes to be 1, and 1 plus sin x goes to 1, right? Actually sin x goes to 0, and secant square also goes to 1. Actually the value of this term is 1. This is not the answer, I know that, and we are trying to prove take the limit x tends to 0 log y. Take out the logarithm on this term. We took exponential on both sides. It extends to 0 y e power 1. So the final answer is exactly the value of limit extends to 0 1 plus sin x whole power cot x equal to e power 1 exponential. And now we are going to solve the fifth and final one problem of this video lecture, and I'll take applying the direct limit, we get 0 par 0 as in a determinant form. Okay, right, now let us take y equal to x par x, taking logarithm on both sides, we get x into log x, right? I write that directly. And now taking limit on both sides, limit extends to 0, we get a log y, and limit extends to 0 x into log x, right? I just rewrite this term as limit extends to 0 log x divided by 1 by x here, right? And we are applying the 0 on these terms, we get infinitive divided by infinitive. Log 0 is an infinitive and actually indeterminate value, and 1 by 0 is also an infinitive value. Okay, we are approaching on both on infinitive, right? And we can use here as L'Hospital rule. So we can differentiating numerator and denominator separately. First, we differentiating numerator, we get 1 by x, then denominator we get minus 1 by x square, right? I'll cancel out the x actually here, and we can comes up to the value of x, we get minus x here, right? We applying the value of x as here, we get this 0 is not a solution for the given problem, but now we are going to remove the logarithm on this side, right? Limit x tends to 0 log y equal to here 0, right? I taking exponential on both sides, limit x tends to 0 e power log y equal to e power 0, and we can cancel out this exponential and log, and we get limit x tends to 0 y equal to 1, right? That means limit x tends to 0 x par x is the value of 1. And if you have any doubt and queries about this video, just text on the comment box. Thank you. Like, share, comment and subscribe my channel for more videos about TNPSC aptitude and CSIR mathematical science, TNC, TRB, Poly TRB. Click the bell icon for more notification for my video. Thank you.